Welcome to Calculus. Whatever confidence you have will be tested. But don't worry, Stevenson has tools to help you. On this episode, Stevenson will demonstrate.
Let's try what we've learned. This is saying, the first one, find f prime of x if f of x equals x squared plus 1. So first, let's write out our rule. Now, let's do our pieces to the side to figure out what is f of x plus h and what is f of x. For f of x, it's just the original function. Now take your two pieces, rewrite your derivative. Now be very careful to distribute this -1 through the second quantity. Now my next step is to actually cancel out any quantities that eliminate themselves. Now I'm going to do two steps in one. I'm going to, in my head, take out a single solitary h to simplify with the h on the bottom here. Finally, I evaluate my limit by taking 0 and substituting it only into h. This is my derivative. This will give me the slope at this curve at any point I want. If I want it at 0, I plug in 0. If I want it at -5, I plug in -5. If I want it on 3/4, I plug in 3/4. This notation is a little different. So what this says is find dy dx evaluated at, you see this bar right here? That means evaluated at x equals 3, if y equals 3x squared. So because I'm finding now what's called a numerical derivative, in other words, I'm finding the derivative at a point, or at a value, I'm going to use a slightly different version of my formula here. I'm going to do f prime at a. So this is what you remember seeing from the previous lesson, except we didn't call it f prime at a, we called it m for slope. Let's do our work. A in this case is going to be 3. Now you're going to take these pieces here and rewrite your limit. Now hopefully you recognize that this constant 27 will cancel out with this constant 27. Now I'm going to do two steps in one. I'm going to mentally factor out a single h and simplify it with the h in the bottom. Finally, I can now evaluate my limit by putting 0 in for h. We have now found the slope of the curve at 3. It is 18. So we just found dy dx evaluated at x equals 3. In this last one now, you will see, again, similar notation, but this time it's not numerical. This just says find dy dx if y equals 7x. Let's start by writing our rule. Now let's put our pieces together on the side. Now that I have my two parts, let's rewrite our limit. You see that the 7x will cancel out with this 7x here. Let's rewrite. In this particular case, there's nothing to factor, but do you notice these h's will simplify? Now this is a constant function. The limit of 7, a constant function as h approaches 0, is automatically 7. So this means dy dx, or y prime, is 7.